Students, in this class we will study the definition of gamma integral. Now, which is going to be gamma of n is equal to integral 0 to infinity e raised to the power negative x times x power negative 1 times dx. So this is very important definition which you have to know when it comes to gamma integral. So having known this, so this would imply gamma of n negative 1 would be equal to 0 to infinity e power negative x times x raised to the power, in the place of n we substitute n negative 1, so it's going to be n negative 1 times dx, which is equal to integral 0 to infinity e power negative x x raised to the power n negative 2 times dx. So this is for n negative 1. Now gamma of n positive 1 would be integral 0 to infinity e raised to the power negative x. In the place of n we substitute n positive 1s followed by negative 1 times dx, which is equal to 0 to infinity e power negative x times x to the power positive 1 and negative 1 gets cancelled, giving me x power n dx. Okay, so you need to know this. Now we are going to study the relationship that connects gamma of n and gamma of n positive 1. So that relationship is nothing but gamma of n positive 1 is equal to n times gamma of n. So this is a very important formula you should know, and it is important that you understand this formula. Now there's another relationship which you have to know, which is we studied that integral 0 to infinity e power negative x x to the power n times dx is n factorial. So this means integral 0 to infinity e power negative x x raised to the power n minus 1 times dx will be equal to n minus 1 factorial. But gamma of n is integral 0 to infinity e raised to the power negative x times x power n minus 1 times dx. So this means gamma of n is n minus 1 times factorial. So this is a very important property also which you should know. Okay, so you can have several deductions, because another deduction can also be like this. So this implies gamma of n positive 1, which is n times gamma of n, can be rewritten as n times n minus 1 factorial. So this is gamma of n positive 1. Okay, so this is an important property also which you should know. Now, having given all this, let us proceed. Students, we are given this question: evaluate e raised to the power negative ax times dx with x power n also being included, and the limits are stretching from 0 to infinity. Now what we are going to do is we are going to make the substitution. Let ax be equal to t. Now when we differentiate this, we get, so this is going to be a times dx is equal to dt, and from here I can write dx to be as dt divided by a. Now I'm going to be using the substitution here, so this is going to be integral. I'm not going to place the limits now. E raised to the power, in place of ax it's going to be t, and in place of x I can rewrite x to be as t divided by a. So this is t divided by a raised to the power n. In place of dx is going to be dt divided by a. I can rewrite this as e power negative d t power n times dt divided by a power n times a, which of course can be taken out and rewritten as a raised to the power n positive 1 times e power negative d times t power n times dt. Now the limits, now when x is equal to 0, t is going to be a times of 0, which is equal to 0, and when x is equal to infinity, t is equal to a times of infinity, which is equal to infinity. So the limits are not changing, but we know that integral 0 to infinity e power negative x power n times dx is equal to n factorial. We know that. We studied in the previous problem. So this would imply 1 over a raised to the power n positive 1 times n factorial, which can be rewritten as n factorial divided by a raised to the power n positive 1, which is the final answer to the question.